Hi everyone, I'm making this video to talk more about growth in tech careers. Salaries in tech, especially in India, are very diverse. Just on entry level alone, you have companies that pay like 2 lakhs per annum, and at the same time, you have companies that pay like 40 lakhs, even in a bad market. So, a gap of 20x. And this gap only becomes wider and wider with more experience, especially if you're not growing in your role. And what's the then way to move up in this ladder and bridge this gap? The only way to do that is by building the right skills and capabilities. Hi, I'm Anshuman Singh, and I'm making this video to deep dive into what it takes for you to grow in your career. I also then want to take you through the scalar curriculum to talk more about how the curriculum actually bridges the gap that I'm talking about. I believe the scalar curriculum is one of the most comprehensive curriculum for your path, but then I'll also show you that. I'm assuming that you are currently a senior backend developer. However, if you're not, then depending on who you are, persona wise, there are links for a similar video based on your persona. So please go and check out the links in the description. Please open the video that is right for your persona. Now, assuming you are a senior backend developer, what is this video about? This video is about helping you figure out what does it take to transition to senior backend roles in product MNC and startup, which has to be your goal going forward. So basically, what does it take in interviews? What does it take in work? Why do most people fail? And then essentially, how does Scalar curriculum cover it? And what are the components within Scalar which are very, very important for you to leverage? Firstly, what is required and why do people fail? So typically, the reason people fail is, I mean, I see that most people, they might not be good at DSA, and they tend to believe that, oh wait, DSA is out of my reach, and hence they never work on their problem solving skill, which is big inhibitor in them moving forward. um, Sometimes, and in fact in a lot of cases, I see people failing because their understanding of system design is very, very weak, especially when asked to design something. They're not able to rationalize decision. Not their fault, a lot of times they're not exposed to some of these technologies. The current work doesn't give them the opportunity to work on these large scale system, and hence, like, when you problem solving for a large scale system, you have never seen it firsthand. You've never learned about it firsthand. It is natural for you to struggle there, and that becomes another blocker for people to move ahead. Third thing is, a lot of times, people even fail to rationalize certain design decisions in their own work. They might be using a tech stack, they might be using a large scale system, they might never have thought deeply about those systems. So when somebody gets into the nitty gritty of it, why is it this way, why not some other way, they fail to give a very, very convincing answer, and hence they tend to fail. And hence, most companies, I mean, it becomes hard for you to get to that level. um, Now, on the very similarly, what I also see is, if there are some people who are able to somehow move to a good company, they also struggle at work. Some of, I mean, because you're a senior developer, typically you'll be going on a senior level. There it becomes important that you are significantly differentiated from an SD1, or maybe an entry level SD2, where you are able to make significantly higher contributions. You're able to guide them, you're able to help with the direction, you're able to actually help other people grow, and your product become better, which people tend to struggle at, and eventually the blame goes to the employer. Look, I mean, again, not to offend you, but a lot of times I see people cribbing about their employers for their own failure. And the reality is, if you work on the skills and you become very capable, some of these would automatically be solved. So today I'm going to be talking about those. I'm going to be breaking it down into two parts. One is where I'll talk about what are the skills that is required both for interviews and work. I'll go one by one. And then second thing I want to talk about is, how is that covered in the scalar curriculum, and how do you leverage it? First thing, as I was saying, in interviews, look, I mean, no matter how senior you are, you could have 20 years of experience, but still DSA is going to be important. You would have a few rounds on DSA. Good news is, except for Google, most companies will not ask you hard DSA questions. They'll ask you questions from any of the topics. could include dynamic programming, could include graph, but they would not ask you a hard question. So that's that. There are going to be a few rounds there. You'll have a few rounds which are tech rounds. So essentially, understanding of basic computer science fundamentals. How do multi-threading work? What are relational databases, indexing, transactions, isolation levels? How do you write SQL queries? I mean, for example, I see a lot of people struggling with window functions. um, so how do you write those kind of queries? How do you have knowledge about your own tech stack in depth? So I'm assuming, for example, if you're a Java developer, then do you understand Java stream and collections in depth? If you're a Python developer, then maybe about Python. One caveat which I would want to call out here is, one other thing which I see in senior developers is they identify as a Java developer or a Python developer or a Ruby developer, which again becomes an inhibitor in their own growth. As you become senior, you're not defined by your tech stack. Rather, your responsibility is to choose the right tech stack for the problem statement that you have. If in your company there is something new to be built, you should choose not because you know that tech stack, but you should choose based on what is the right decision for the requirements that are there. Hence, on senior levels, it is extremely important to have the skill of being able to learn a new tech stack quickly. At Facebook, I worked on three different tech stack, and I was given 1 week to learn those tech stack. You should also have that. That is going to be required from you. So yeah, I mean, another thing is advanced language constructs. Apart from tech rounds, then you have design rounds. Within design rounds, firstly, I mean, as I said, there's going to be deep diving on your previous work. If you use MongoDB, then why did you use MongoDB? How do you scale MongoDB? How do you shard MongoDB? There will be questions like that. Um, Second thing is, how do you use design patterns in code? Which is, are you capable of writing code or reviewing code to make sure it remains maintainable and extendable for the future? Are you really good with schema design, API design? Again, same. How do you make sure there's no tech debt? When it comes to architectural system design, then given a case study, let's say Uber or Hotstar or whatever, are you able to design a large scale system or not? Nowadays we also see that a lot of companies focus on microservices. So when it comes to microservices, things like design patterns, saga pattern, distributed tracing, API versioning, all of that um, comes as part of microservices. And there are some companies like Flipkart, Udan, etc., who do a machine coding round where they'll give you something to build from scratch in 90 minutes, and then they will ask you questions on why did you build it a certain way, what kind of design pattern did you use. You'll also have some questions which are around cultural fit. How are you working with your team, with your manager? Do you fit culturally or not? And are you really keen to join the company or not? Now, all of what I have described for interviews are also important for work. That is the reason why it is part of interviews. However, there are certain other things that are important for work, success at work. One is, as I said, like you should not be married to a tech stack. You should be comfortable with learning new tech from document. This also includes new tools, new libraries. You will be required to learn them quickly. So one skill that you have to develop is, how do you read documentation and learn things? How do you work with large code bases? The second skill is, as a developer, your job is not just writing code, but it's also going to be making sure things don't break. If there's an issue going on, you're able to go and resolve those issues, which means you have to be good at troubleshooting, which means you have to be good at logging into remote machines, being able to, let's say, parse logs, being able to look at current running processes, and a few other things. I mean, being able to analyze network stats, and hence be able to finally troubleshoot where the issue might be coming from. Basic familiarity with cloud is also important. Basic familiarity with CI/CD pipelines is important. But most importantly, one of the factors for your growth, which basically helps your product improve, is your ability to deal with ambiguous problem statements. Problem statements that don't really have a very defined solution, but you have the ability of breaking it down into small, small parts to finally get to the solution. For example, you could be said, hey, look, here is a service. Let's say this service today takes 500 milliseconds, which is unacceptable. We have to get it down to below 150 milliseconds. Now, the service could have lot of components. For example, let's say that service is messaging service. The messaging service could have a lot of components. You could be storing messages. You could also be sending notifications. Um, you could also have maybe some job there, etc., etc. Right? So when somebody says bring it down to 150 milliseconds, you don't know whether that is feasible. But then if you start breaking it down, where is time being spent? Then what are the scope of optimizations there? Can I cut something? Can I make something faster? Can I optimize something? Then maybe you can probably reach to a solution. That's a very basic example. Typically, you'll do a very similar kind of problem solving from a product side as well. So hence building the right product sense and the breaking down of problems into small chunks, that becomes a very very important skill at work. Your soft skills, which is how do you communicate with your teammates, prioritize, design, all of that also becomes important. In a way, you have to make sure there's visibility of work, otherwise you will not get the right attribution. Now if that makes sense, that wait, these are the skills to build, I will show you that while this might sound very overwhelming, there is a path which can help you teach this in a structured fashion, or help you at least push on the path to learn this in a structured fashion. Now we come to the curriculum. Now, for while Scalar actually offers backend track, full stack track, data engineering track, etc., for you, my recommendation would be stick to backend. Better to go more deep rather than going too broad. So, if that's the case, let's actually go over what the curriculum looks like and how it solves for what you need for interviews and or for job efficiency. Uh, no surprises. The first module is DSA, which goes on for 5 months. Very comprehensive. All topics are covered. Every class is followed by a set of assignments, which are coding questions, very similar to the interview coding questions, but you get to practice it, you get to solve it yourself. The idea with this module is that how do we build your problem solving ability? The idea here is not to dictate solutions to you. The idea here is not to give code to you, but rather build that part of your mind which can think of innovative solutions when they get a new solution, right? So building that part of your muscle. Now, the relevance for interview is very clear. Look, I mean, 2 or 3 of your rounds are going to be on DSS, so it is definitely very, very important. One other thing, however, is that look, it also helps with job in ways you might not have thought of. For example, if you do DSA, I mean, one of the things you get really good at is your accuracy of coding. You try to get your code right the first time. Now, if that happens, then you make lesser bugs, your productivity increases. Two is it develops a mindset where you think, like by default, think of efficient solutions. Writing solutions which are not efficient almost gives you cringe. Three is when you start to learn about system design and large scale systems, when you get deeper into their architecture, you start to realize that all databases, all large scale systems, they actually under the hood use a lot of DSA. So understanding those systems then becomes easy for you if your DSA knowledge is solid. For example, like something as simple as a relational database uses B plus trees under the hood. If you know how trees work, understanding B plus trees and then how a database works becomes super simple. Now, one of the assumption here is that look, you already know coding. If you don't, then like for beginners, which is if you're a beginner, then there is a 2 month of teaching you a programming language before DSA, which is in Java. However, I mean for you, I'm assuming that's not the case, and hence we directly start with DSA. The module after that is relational databases, which goes on for a month. Now, this module, the primary use case of this module is look, it will teach you to be good at schema design, indexing. So, essentially, what kind of indexes to build, or if there's an index, then like what kind of queries does it affect? Transactions and isolation levels, which is to say, hey, look, I mean, what kind of locking or isolation level do I need for a given use case? How does it affect my performance? Writing complex queries, I see a lot of people fail when they have to write queries that involve window functions, etc. In fact, even as soon as the queries get more complicated with more joins, people start to struggle. Again, as an engineer, you're expected to be able to write complex SQL queries, so that gets covered. So you have joins, aggregation, window functions, subqueries, views, CRUD, etc. um, and I mean, this helps because in your interviews you're going to be questioned on schema design. You're going to be questioned on writing certain SQL queries, indexing and transactions. In fact, maybe a deeper dive on like how things are stored internally inside a relational DB. You might also ask me the question, hey, look, this is relational DB SQL, but what about NoSQL? Don't worry, NoSQL is covered in system design module and the advanced project module, which we will talk about later. At work, this is important because 90% chances are a lot of systems you'll be working with use relational DB in the background. So if you're building for relational DBs, obviously good to be solid with that. You should know what kind of schemas work best. You should know how to run queries, how to fetch information, what should have index. Otherwise, your system will become really, really slow. Once you're done with that, then there's an optional module of a month, which is project. Um, Now, this project module is optional because one of the things I'm assuming is all of you have prior experience in backend. You would have built some project. But reason why I say that it is optional also is that there's some of you. I mean, in India, like the experiences are very varied. Like, so it is not necessary that you have done decent project work either. If you have, great. If you have not, then please do this module. This module basically covers basics of Git, um, basics of a framework, in this case Java Spring Boot, REST APIs, how to handle exception, um, how to build authentication systems, um, how to do schema versioning, how to get started with cloud on AWS, for example. How do you set up EC2, RDS, basic deployment processes, VPC, DNS. How do you set up metrics and measurements? How do you integrate an external API, especially like something which can become very complex? So, for example, payment gateway. Integrating gateway is the real deal. So we help you integrate a payment gateway here. Um, Pagination, searching string. How do you optimize your APIs? All of that is covered in the project module. Now, you'll notice that this is done in Java Spring Boot. And I'll go back to what I said earlier, that as an engineer, um, you have to be language agnostic. You have to be tech stack agnostic. You have to be open to learn new tech stack when required. So by just doing a project in Java Spring Boot, even if you're not a Java coder, it helps you unlock more opportunities instead of doing any harm. So my recommendation would be, please learn and do it. However, if you have reservations, if you say that, look, I do not want to learn a new tech stack, however, I still want to do a project module, in those cases, a bunch of concepts that are covered here, they are language agnostic. For example, how to do authentication, schema versioning, how to set up cloud, etc., 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 is all language agnostic. Whichever part is related to the language, there we also give you recordings in different languages. We also give you documentation in different languages. And in this module, the assignments also support Java and Python. So there are assignments where you have to build a feature. There are assignments where you have to, let's say, build an extension of what was covered in the class. um, and as you, let's say, do those assignments, we have unit test cases, etc., which are run to judge whether your things are working well or not. Those support both Java and Python, and hence your project happens from there. Now, this is helpful in the interviews because, firstly, projects or high quality of projects help with resume shortlisting. I'm sure like your previous experience helps there. But there are questions on MVC frameworks. There are questions on like how certain things work, for example, authentication, or let's say how certain things might work um, in the context of schema versioning, exception handling, etc. So you'll be able to handle that. In general, this is backbone of your job, right? This is what you'll be doing day in, day out. The one other thing that I also want to mention on the assignment piece, for example, in the last module I mentioned that you'll be doing schema design. Here you might also be doing API design in projects. All of those also have assignments. So we have actually integrated AI to be able to do these kind of assignments where you create a schema design, and we are able to then give feedback and scoring or suggestions based on leveraging the recent LLM models that we have. Anyway, moving on. Post that, we have advanced language. Again, there we covered OOPS, concurrency. Concurrency is multi-threading, and like language advanced concepts. Now, in multi-threading, you have to think of like, look, I mean, how do, let's say, multiple threads coordinate between themselves? If I want one thread to do something, another thread to do something, and like I want them to be able to uh, multiplex in some ways, then how does that happen? How does synchronization happen? How do mutex and semaphores work? All of that is part of your concurrency module. Um, So post this module, you'll be able to comfortably think about when, in what cases race conditions might occur, what are concurrent data structures, and how do you synchronize a piece of code. um, Post that, there is advanced concepts in a language. We do live classes for Java for certain advanced concepts. However, again, if you're from a different language and you want to go deeper there, we share recordings as well as documentation of certain questions that are likely to be asked in the interviews, or likely that you will end up using in your job frequent times. So as long as you have that as a cheat sheet, you can just keep referring to that. um, Post the advanced language module, which is of a month. By the way, just also mentioning here, the assignments, all kinds, right? So we basically have MCQ assignments, we have coding assignments, we have these assignments where there are unit test cases that are written, there are certain AI driven assignments. A bunch of those assignments here like exist here as well. For example, for multi-threading, we give you assignments where there might be race conditions, or maybe where we have multiple threads and we want you to be able to coordinate between those threads. Post the advanced language, there is the low level design module. Now again, I can talk about a bunch of these design patterns that are written here and like a bunch of these case studies written here, but let me tell you where people fail here, and hence it derives what is there in this. We see that most companies, they focus on three kind of interviewing rounds for low level design. One is knowledge based, so they would just straight up ask, hey, look, what is singleton design pattern, or what is a adapter design pattern, or what is a factory design pattern. um, there are some companies who would not do that. In fact, better companies don't tend to do that. They would rather give you a case study. They would say, hey, look, I want to build a book my show, or I want to, let's say, design a software for a parking lot. How should I go about doing that? And you're required to sort of gather all kind of requirements, and then maybe build the right class hierarchy, build the right kind of schema. And that's where you'll be using some of these design patterns to make sure you're following the right practice. And the third kind of rounds, which typically happens with companies like Flipkart, Udan, etc., is the machine coding round, where you will be asked to build a prototype of a basic um, application like Book My Show or Splitwise or Google Calendar. There, your schema design, your API design, your class design, all will be tested. And you don't have a lot of time to do that. You probably have like 90 minutes to build a basic prototype. Need not look great as long as it is functional. And there, what you're judged on is how did you design the schema, API, and class architecture. Keeping that in mind, everything that is required for that is covered as part of this low level design module. um, Chances are, either at SD 1 2 3, whatever kind of interviews you go for, you will be judged on low level design. It also helps you at work because this helps you write the right kind of maintainable extendable code in your company. It helps you do the right kind of code reviews, just to make sure you're not only building for today, you're building something that will last for later as well. Assignments here, again, very similar kind. Either asking you to build something where unit test cases already exist, um, or maybe helping you, asking you to design a class architecture, which again is just through AI. So a combination of both, and in some cases maybe some MCQs as well. Every class, however, has assignments. Finally, actually, second last is the advanced software engineering module. This is where we try to get you familiar with the larger systems that you might be likely to work with. In fact, most companies expect you to know certain things about these kind of systems, right? So for example, as I said, a lot of companies have recently started asking a lot of questions on microservices and their design patterns. And we try to get you hands on there. Certain companies ask questions on Kafka. For example, how do you scale Kafka on a particular topic? Essentially, how do you create multiple partitions? How do you have more consumer groups? Now, you can't do all of that unless you've done something which is hands on with Kafka. Or how do you do, let's say, a full text search? Now for that you'll have to use Elasticsearch, but then like how do you build a basic index on Elasticsearch, etc. So again, we try to get you hands on those things. How does an internet work, right? So what happens, let's say, when you type google.com and press enter? um, More from from a networking standpoint, um, all of those is covered here. So we cover things around Elasticsearch, messaging queues, Kafka, networking, microservices, basic Spring Cloud, logging monitoring, containerization like Docker. Now, while this is very, very relevant to interviews, it's extremely relevant for work as well. Chances are all of this will be relevant for your work wherever you go. Um, Now, one of the other things, by the way, one of the other philosophies that is, by the way, driving this module is that through this module, one of the things we will push you for is reading documentation and learning from the documentation. We are there to help you, but here and in some of the earlier modules, we try to build the habit of also learning on your own, so that by the time you're done with Scala, it's not that then uh, you're in the habit of being spoon fed. You also have to become self capable, right? So we try to push you more aggressively on this path where you start to learn on your own as well. The assignments here again very similar. Implement feature, build something, and we have test cases around that. If you're building something on Kafka, again test cases around that. Post that, the last module is the architectural design or system design HLD module. Again, we start with the building blocks, caching, cap theorem, master slave, multi master, NoSQL databases again, and why what they needed, and then like what's their architecture like for different kind of NoSQL databases. Again, we, for example, we get into Cassandra's architecture. Um, and then we do a bunch of case studies. So Google search type ahead, Messenger, um, like Google Maps slash Zomato, Uber, Hotstar. We do certain smaller case studies as well. For example, rate limiting system, or distributed ID generator. Um, or I mean, we try to also design certain systems that we exist. For example, Kafka, Elasticsearch, Zookeeper. Like, how would you, if that was posed as a design problem statement to you, how would you have gone about designing it in a way where it scales, it's capable of scaling? Now, again, this is where the assignments are designed in a way where you're given situations, and in those situations, what is the right answer? Mostly MCQs, or like a number as an answer, which if you understand the design well, then you'll be able to answer. This is extremely relevant for all kind of system design rounds, all architectural design rounds in the interview. However, I mean, it is also important at work, because without this, to be honest, your progression to senior engineering roles is impossible. You have to be able to participate in team design discussions. It is in a way prerequisite for promotions. um, and I mean, the part about being able to solve ambiguous problem statement doesn't happen unless and until you understand architectural designs really well. You have a good hold on that. Once you're done with that, that's your mandatory part of the curriculum done. You also have two electives. Again, you can choose not to do them. However, if you ask me, I would suggest please do the elective on product management for engineers. This actually trains you to be able to take a problem statement, think of it from a product first standpoint, break it down into small, small parts, makes you good at solving ambiguous problem statements. Hence, that elective is there. The second elective is data engineering elective. This is very relevant if imagine your company does deal with a lot of data. Sometimes you will get to work with data engineering teams, data engineers. You might be involved in a data migration. You might be involved in setting up a data warehouse. In those cases, having gone through this module, that journey will become super easy. In fact, if later you want to become a data engineer or just explore it, again, becomes super easy. Um, Now, this is the rough overview of the curriculum. However, just the curriculum itself does not really help. It gives you structure but doesn't help. I'll tell you what exactly helps. Firstly, I talked about assignments. They really help because they help you apply everything that you've learned. Two is the biggest problem that I hear from everybody is completion, which is people start on this journey but never complete. Now, for completion, what helps? So, firstly, we do live classes so that There is some schedule that is enforced. um, in a way, we help you build that discipline, and you have somebody you can ask questions to, so that helps. Third thing is, you're not doing it alone, you're doing it in a community. You have people exactly like you, senior backend engineers, junior backend engineers with you, who you are going through a very similar journey, so you can ask them questions. You can get inspired by them. You can also help use them, by the way, to unlock more jobs, if at all it comes to that. So that helps. You have a one-on-one mentor, and this is actually very, very important. um, I would recommend that you should schedule regular sessions with your mentor, not just because the mentor will check on with you on your progress, but the fact about somebody has to actually spend time poking on your previous experience, asking you difficult questions, on why a certain thing was done in a certain way. That your mentor can do, and can also give you feedback on how should you present your previous work, how should you present yourself. At some point of time, you'll have to build your resume. How do you build your resume which is impressive? All of that your mentor can help with. You have your one-on-one mentor, you will select that, and that's your coach in your journey, apart from your instructors and TAs. You also have TAs. They help you get unblocked whenever you're solving a problem and you get blocked. Again, also helps with completion. So, and then you have a very gamified interface, which in a way makes it very fun to come to the platform every day, solve problems, right? All of that comes together to actually help increase the probability of your completing. Now, if you want to again see numbers on what are the completion rates, etc., at Scalar, how why is this ecosystem very, very important? There is a link that I have attached in the description of the video. You can go and watch it. Um, However, I mean, you could also start the journey on your own, with or without Scalar. There is, what I would suggest is, like, there's there is a lot of opportunity for growth within tech. As I said, this is the blueprint for growth. Focus on your skill, focus on learning. If you do that well, then growth will happen. I hope that helps you. I hope that helps you get started with your journey. Thank you.